West Bridge over Storebælt, the Great Belt in Denmark, is the longest bridge in Europe. The contractor consortium ESG, European Storebælt Group, won the contract to build the West Bridge because they based it on a unique concept, namely on the idea of almost total prefabrication. For the first time in history, every single element was built on land. Working on land was both easier and safer than working on the water. The advantage of prefabrication lies in a stable working rhythm and the best conceivable possibility of keeping to a timetable. It was Kurt Offerson, the foreman for the reinforcing work, who put forward the idea of prefabrication. During his work on the Great Belt Link, the fundamental ideas for a completely new reinforcement system came to him. Briefly, this revolved around prefabricating some ladders or frames that the reinforcement could be tied to. The Arm-Tec reinforcement system was used for the first time in the work on Øresundsforbindelsen, the permanent link between Denmark and Sweden. This tunnel section, complete with roadway and railway, shows the principle of the Arm-Tec reinforcement system. When the concrete layer is removed, a reinforcement cage appears. This is completely built up around prefabricated frames. The frames are used for the base, the walls and the top in the tunnel section. When we look more closely at the wall frame and remove the reinforcement, we can see where the projections have been made for placing the horizontal reinforcement. When this is in position, the vertical reinforcement is tied to it. The frames are an integral part of the complete reinforcement cage and are cast in with the tunnel sections. From the frames, you get a general view of the shape of the finished concrete construction right from the start of the reinforcement work. The shape is shown in advance by the frames. The first basic ideas for this new reinforcement system were tried out during the building of the Great Belt Bridge. Already there, the reinforcement work went quicker and more efficiently. From the contractor's own experience, figures showed that by using ladders or frames for reinforcement, working time for this assignment could be reduced by up to 50%.
Det er Djurhus.
Carl Djurhus was the section engineer responsible for the production of the pier shafts for the West Bridge. It was here the biggest savings with the new reinforcement method were achieved.
Man kom ned på nogle tider, som man slet ikke havde kendt før. Jeg vil sige, at man fik mere end halveret armeringstiderne, som man havde planlagt med. En anden fordel var, at man fik armeringen anbragt helt præcis, og i begge retninger kan man sige, disse stiger eller rammer, de gav jo både afstanden mellem de vandrette jern, men de gav også afstanden mellem de to armeringsnet i pillerne.
The Arm-Tec reinforcement system is being used for the greater part of the reinforcement work in the building of the permanent link over Øresund. The method is used by Sundlink contractors for producing the caissons, pier shafts, and railway troughs for the Øresund Bridge. Peel and Orslef for the support walls on the abutment at Copenhagen's Kastrup Airport. Midrock construction in cut-and-cover tunnels in the abutment in Sweden. And Øresund tunnel contractors in the production of tunnel elements. The tunnel elements are produced in a big production hall at Nordhavn in Copenhagen. The Arm-Tec reinforcement system has made it easier and quicker to apply the reinforcement. But significant savings have also been made because the method affords a continuous production process without wasted time. The reinforcement sections are built in a hall at Øresund Tunnel Contractors next to the casting form. The form is therefore only used for casting work. The reinforcement work and the casting are now two parallel processes. and this allows the reinforcement workers to work more continuously, giving a better flow in the reinforcement, forming and casting work. The main reinforcement is no longer used for shaping. The frames do this. The main reinforcement is now only responsible for the strength of the construction. By this means, one saves on the amount of reinforcing iron used, and a great deal of the difficult and time-consuming work of support reinforcement is avoided. The use of separate brackets and hooks to keep the shape is no longer necessary. Thomas Skjold has been in charge of the reinforcement production planning at Öresund Tunnel Contractors. Against the background of the complete project model, he was instrumental in making the decision to use the Arm-Tec reinforcement system.
Man skal være tidligere ude med ens planlægning, fordi armeringen den skal ligesom planlægges til at passe til rammesystemet. Man skal ligesom få det hele til at passe sammen. Derudover så har man den fordel, at man kan på ligesom tegnebordet planlægge frem i tiden med hensyn til alle dimensioner af konstruktionerne, så måltagning ude på selve pladsen bliver minimal.
The frames in the Arm-Tec reinforcement system ensure the precise positioning of the reinforcement so that it can cope with severe tolerance requirements. The reinforcement sections fit exactly when they go into the casting form, and the tolerance for the finishing coat is down to under 3 millimeters. Extra advantages for the working environment have also been gained. The reinforcement workers do not have to support the iron anymore while it's being fixed, but only have to lift it up onto the projections. In this way, the frame system can live up to future working environment legislation.
Det noget nemmere det her, rigtig nemmere. Fordi at, det er klart nu, ikke det hele. I stedet for at vi skulle have lavet ret jern op og stå og bøvle med alt det, så er det bare at lægge op på hylderen nu, og så kommer det ud af. Og det passer, der er ikke noget med, at begge vægene er med, ikke? Altså, det er ikke noget med, at vi skal stå og lave en enkelt væg og have stole imellem for at få det til at passe.
The Arm-Tec reinforcement system saves a lot on costs for cathodic protection because the frames that form a ring round the complete construction are in contact with a great deal of the reinforcement. Therefore, one doesn't have to weld the reinforcement together at very many points, and so one avoids having to put in supplementary reinforcement. The Arm-Tec reinforcement system can also be delivered complete with a cooling system for assignments where it's necessary to cool down the concrete. This system is being used by Sundlink in the pier shafts and caissons. The Arm-Tec reinforcement system is used in some of the world's biggest construction projects, but the method is also suitable for smaller constructions. There are no restrictions with regard to dimensions or types of reinforcement. Most smaller projects can also be carried out quicker and more easily with the Arm-Tec reinforcement system. In cooperation with a contractor, Arm-Tec can work out optimum solutions that can be adapted to each individual project. Working drawings like a cartoon series can be supplied. In other words, the positions of the frames and the reinforcement are illustrated in the various consecutive phases. As an example, we're showing here Arm-Tec's solution to the reinforcement of a tunnel using prefabricated frames. A project can also be supplied as 3D files on a floppy disk. This enables a customer to use his own computer to evaluate the reinforcement construction. Arm-Tec reinforcement system is a total solution that affords better economy, greater efficiency, better quality, broader perspective, better working environment. Arm-Tec is ready to create the frames for building projects of the future.